Solving a system of linear equations using elimination with multiplication and addition. Example 1. Solve the following systems of equations. So I have a system of equations here. Whenever I'm using the elimination method, the first thing I want to check for is that both of the equations are in standard form, which, if I look at both of these two, the x's and the y terms are both on the left side of the equals and the constant terms are on the right side. So I have both equations in standard form. The next thing that I need to look for is one set of terms, either the x pair or the y pair, that are exact opposites. So one of them positive, one of them negative with the exact same coefficients. And if I look here, I don't have that situation with either my x's or my y's. I do have the opposite part. This x is negative, that x term is positive, this y term is negative, that y term is positive. But I don't have the matching coefficients, and I need exact opposites. So I'm going to have to multiply one or both of these equations by a number to get what I'm looking for. So let's just go with the x terms, and you can choose either. I could do the y terms, but I'm going to just go with the x's here. I have one negative and one positive, but I need the same coefficients now. So 8 doesn't go into 9. They're not set up where one is a multiple of the other already. So I'm going to have to multiply both of these equations by something to get the opposites I'm looking for. And you can use the least common multiple if you're trying to keep your numbers small. Any multiple of the two will work. I'm just going to multiply 8 times 9, okay, and use that as my multiple. So if I want one negative and one positive, and 8 times 9 is 72, then I want this one up here to be negative 72x, right? That's what I'm looking for. And I want this one to be positive 72x. And again, I came up with the 72 by just multiplying these two numbers together. I know 72 is a number that both 8 and 9 will go into. So if I want this 8x to become negative 72x, I need to multiply this first equation all the way through by 9. Every single term. So this equation, this top one, when I multiply every single term by 9, 9 times negative 8x is going to be negative 72x, which is what I was going after. 9 times negative 9y is going to be negative 81y. And 9 times negative 9 is going to be negative 81. Now this bottom equation, I'm going for positive 72x here. So I'm going to multiply this bottom equation by positive 8. So 8 times 9 will give me positive 72x. 8 times 8y is positive 64y. And 8 times negative 9 is negative 72. So by multiplying both equations, right, by a factor, I've created exact opposite x terms, positive 72x and negative 72x. Now, I'm just going to use straight column addition to combine my like terms. So negative 72x plus 72x is 0 x's, right? The x's have been eliminated. But in the y's, I have negative 81y plus 64y, which leaves me with negative 17y equals, and then negative 81 plus a negative 72, or subtract 72, is negative 153. To isolate my y or get the y by itself, now I'm going to divide both sides by -17, and my y value is 9. So now that I know my y value, I can use either of these two original equations and plug in 9 instead of y and solve for my x. So I'm going to choose the bottom one because it has positive x and y terms, and this one up here has negative x and y terms, and no other reason than I guess I'd rather deal with the positive numbers than the negative. So I'm going to use this bottom equation, 9x plus 8y equals -9, and I'm going to substitute this y value right here into that y so that I can then solve for my x value. So this 9 is going to go right up there in place of that y. So 9x plus 8, and in place of y, I'm going to put 9 equals -9. So 9x equals 72. Oh, excuse me, 9x plus 72 equals -9. Subtract 72 from both sides. 9x equals -81. Divide by 9, and x is -9. -81 divided by +9 is -9. So my solution here, x equals -9 and y equals +9. If I was going to graph it, the point of intersection or my coordinate pair would be -9, 9.